Good morning, everyone. My name is Bhanu Prasad Gollapudi, and I am currently pursuing my PhD in Doctor of Business Administration at Westcliff University. This presentation is part of my current course for DOC700, Doctoral Foundation subject, under the guidance of Professor Dr. Jodi Consten. Thank you, Professor. Today, I am excited to present my research on improving the accuracy of CPDP models or cross-project defect prediction models using domain adaptation and deep learning techniques. In this current project, I would like to explain about the introduction about my current research, literature synthesis, literature gap, research design and methodology of my current research, what are the different research questions I choose to perform this current research, what are the different types of the data I used it, and what are the methods I use to collect the data, and ethical consideration and conclusion and significance of my current research, what are the different peer-reviewed articles I gone through to perform this study. I'll explain this. Introduction about CPDP models. So as you know, in software engineering, defect prediction models help us to find the fault-prone areas in code before testing even begins. That means in real-time software industry, how it will how the regular way is that once you're done with the development of the code, you will hand over to testing team to find the fault-prone areas in our code. So using the WPDP models before testing begins, you will perform some of the WPDP models functionality. You will find the fault prone areas. So, but traditionally, within project defect prediction or WPDP models perform well only when historical data from the same project is available. What about the historical data is not available? Then at this time, CPDP is coming to the picture. It tries to predict the defects in a new project using the data from the other project. However, CPDP model also has some limitations. One of the major limitation or the struggle for the CPDP model is domain shift effect. That means domain shift effect means there is a difference in programming languages, architectures, and design patterns of the project implemented based upon the targeted audience. So one of the major impact for the CPDP models is domain shift effect. So in my current research focuses on improving the CPDP accuracy by integrating the three components. One is that domain adaptation techniques, deep learning methodologies, and robust data pre-processing methods. So by using these three methods, I would like to address the domain shift effect of the CPDP models, which may effectively improve the accuracy of the CPDP models. The previous researches highlight several challenges and opportunities of the CPDP models implementation. So the major thing is that domain shift effect. As I mentioned earlier, due to the differences in the code languages, style, and structure across the different targeted audience, the implemented project often face the problem of domain shift effect. And also class imbalances or imbalanced data sets lead to inaccurate predictions. For instances, so what is imbalanced data means like the CPDP models perform as a misclassify non-defective code as a defective ones and defective code as a non-defective ones. And recent methods like TOMO, that means transfer learning oriented minority over sampling technique. The technique help us to find the combination of feature weighting showed a better prediction performance for the imbalanced classes. So like to imbalanced classes means like to find the non-defective ones as a defective ones and defective ones as a non-defective ones. So using the TOMO, that means transfer learning oriented minority over sampling techniques will address this issue. And also graph-based deep learning helps to extract the structural and relational feature from the code to improve the transferability. So as you know, most models still lack the semantic understanding of the code. That means they only capture the what code is doing, what is the relationship between the classes. That's what they will do it. But how the code was written, but they are failed to understand the semantics of the code, like in depth how there was a relationship between these two classes, the semantic understanding. The current model failed to address these issues. So if you perform the research gap of the current things, if you see that challenges in the CPDP models, there is 40% of the issues are domain shift issues, and 20% are related to lack of semantic understanding, and 25% are class imbalances, and remaining 15% are other limitations. So that means like if you want to go dig deeper into this challenges of the CPDP models, many models still fail to handle the domain shifts effectively, and focuses is largely on surface level features like metrics and code structure without understanding the code semantics. And one of the major issues is that the data sets are often contains noisy or irrelevant data that impact production accuracy. And like most models does not explain their predictions. That means like they are fail to apply the models and tools like SHAP and LIME. SHAP means shapely adaptive explanations, and LIME means local interoperable model agnostic explanations. So these two tools will explain the uh, fostering developer trust and adaptation. So using these two tools, like we can understand the semantic structure of the code and everything. So most of the existing models fail to apply these two tools for the existing CPDP models. In my current research design methodology, I would like to go with quantitative correlation study. So quantitative correlation study means uh, majorly in my research, I would like to go with numerical data, and also the research using the existing data, existing studies. And also why I would go with like correlation means I would like to explain the how the variables are related to each other. I don't want to explain the caution and all. I don't want to manipulate the variables and all. I would like to explain the relationship between the variables. And also here for this current research, I would like to collect the data from the secondary data sets. That means the research between the existing data sets and also publicly available data, promise NASA, MDP, GitHub, and previous studies. So this data is publicly available, and where everyone can easily access those data and can do the research about this existing research projects. And also, if you see the diagram of my current research about, like I would like to go with source project and target project. Using the source and target project, I would like to select the feature selection of my current project, and I would like to apply the SMORT, which is a deep learning methodology, to find the class imbalance pre-processing and removing the noisy data and balanced data sets, to find the selected sources and selected target projects using applying the sum of the domain adaptation techniques, and to find the prediction results. So this is what I am planning to do it in my current research. So before going to the dig deeper into that one, like I would like to do, as I mentioned, like data preparation methods is one of the crucial step of the training of any machine learning models. So in this one, data preparation models, I would like to do with handling the missing values, encoding the categorical data, normalize and standardize the features, and feature selection. Once the data preparation is done, I would like to once I got the results, I would like to perform the data analysis. For the data analysis, I would like to perform the sum of the tests like Pearson correlation and statistical significance. And once I got the data analysis for the visual tools, I'll go with scatter plot and correlation matrix and bar charts. That's what I'll do it. And for my current research, this study is driven to two core research questions. The first question is that what is the impact of domain adaptation techniques on the predictive performance and accuracy of the CPDP models? And the research question two is about what is the impact of pre-processing methods like data balancing and feature selection on CPDP models accuracy. So for each, I define a null and alternative hypothesis. If the data shows the statistical significance, that means like p-value is less than 0.05, I will reject the null hypothesis and conclude the method is, in fact, it improves the accuracy. So, like if you see my current block diagram I explained here, so there is a source project data is there. I'll apply the domain adaptation techniques and for the CPDP defects target projects to accuracy evaluation. So that means like I took the source data project and I apply the domain adaptation techniques, and for the CPDP target project, I'll apply based upon the p-value, I evaluate the accuracy. Okay, coming to the data collection methods, I'm using the secondary data sources that are well established in defect prediction research. This include software metrics and bug reports, code module information, and historical data from previous studies. So criteria for selection is that relevance to the problem and the data quality, past use in research to ensure the compatibility between the relationship between the previous methodologies, and also publicly available datasets widely used in defect prediction studies, including the Promise repository, NASA MTP datasets, and GitHub open repositories. If you see the secondary datasets, like majorly I'm targeting on like three types of the datasets. One is that published research papers, that means previously available research papers, experimental results, and public datasets like Promises and NASA and GitHub projects. And coming to the ethical consideration, uh, for my current study, I would like to perform the ethical considerations. So once ensure, like I would like to ensure the data from the multiple sources is collected and shared ethically. And also I would like to use IRB, Institutional Review Board, to review, assess risk, and protect participants, and maintain the confidentiality and anonymity of any human subjects. That means like when I would like to do collect any companies or any enterprise related personal data or personal project data, I would like to maintain the confidentiality or anonymity of any human subjects, handle the sensitive or proprietary data securely and responsibly, and promote transparency and integrity in data use and reporting, ethical compliances, and strengthens the credibility of the CPDP research. I would like to do this all ethical consideration before I'll start my research for my current research. So coming to the conclusion and significance is that to conclude my current research, my research explores how domain adaptation and deep learning can significantly improve the accuracy of the CPDP models. It improves the evidence that pre-processing, especially balancing and feature selections, plays a key role in production success. These findings can help software teams catch bugs earlier, reduce testing time, and lower maintenance costs. Ultimately, it contributes new knowledge to the field of software defect prediction with a practical applications in industry. So these all are the references. These are the references and peer-reviewed articles I use to perform my current research. Thank you. Thank you so much, team. Thank you, Professor Jodi Consten.